Alright, good morning. This is Math 111. Today our lecture is going to talk about section 1.3 in our text, operations with real numbers. Now, it's basically a review of simple arithmetic operations, certainly stuff you should have encountered before in your mathematical careers, typically in a first algebra course. And let's just get right to it. I'm going to grind out a bunch of examples, get our hands dirty right from the get-go. Add. How do you add real numbers? Well, some people call these sign numbers. They're really integers. Integers are nothing more than the positive and negative whole numbers. And of course, we know that minus 5 plus minus 3 is negative 8. So I'm not going to belabor that. Let's move on to something a little more difficult. Minus 13/6 plus 3/8. Well, fractions are real numbers too, so how do you add these two fractions? Well, of course, to add fractions, you need a common denominator, and I believe the LCM, the least common multiple of 6 and 8, is 24, is it not? So if I want to express both of these fractions equivalently with denominators of 24, I've got to multiply the top and bottom of the first fraction by 4. I get a negative 52 then in the numerator. And in the second fraction, I'll multiply top and bottom by 3, which will give me 9/24 equivalently. And then when I've got the common denominator, I can add or subtract the numerators as indicated, and I'll end up with a minus 43/24 as a final answer. Let's try another one. Minus 11/12 plus 13/9. Well, I suppose anybody can add whole numbers. Can you add fractions, especially signed fractions? Well, that's part of the game here. Minus 11/12 plus 13/9. What's the least common multiple of 12 and 9? I think it's 36, is it not? So if I want to add these two fractions, I've got to get a common denominator, and I think the least common multiple of 9 and 12 is 36. Alright, I'll multiply the first fraction, top and bottom, by 3. I'll get minus 33 over 36. Multiply the second fraction by 4, and I'll get a 52 out of 36. And then I can add or subtract the numerators as indicated, and I end up with a 19 over 36. 19 is prime. 36 is not a multiple of 19, so that would be our final, completely, most simplified answer, 1936. Alright, so now that we're expert in adding real numbers, let's try to subtract some real numbers. And I don't want to insult anyone here, but minus 2 minus 8 is, of course, minus 10. So I'm going to assume that we've had much experience with adding, subtracting integers in algebra courses. And let's talk about something a little more difficult. Minus 14/3 minus 8/9. Alright. How are we going to handle this? Well, of course, to add fractions, positive or negative, you need a common denominator. Well, I think we'll see right off the bat that when you subtract a negative, it's equivalent to adding the positive, or adding the opposite of minus 8/9. That would, of course, be 8/9. Alright, so things look better already. I'll want to multiply top and bottom here by 3 to get a common denominator of 9, right? So I get minus 42 on top divided by 9 on the bottom, and add to that positive 8/9. We go back to yellow. So minus 42/9 plus 8/9 is minus 34/9. And that would be your final completely simplified, most final completely simplified answer. Alright, how about if you get a string of negative values, positive and negative values? How do you handle this? Well, when I subtract a negative 1, that's like adding 1. So subtracting a negative becomes equivalent to adding a positive. Minus 11 plus 1 is minus 10. And minus 10 minus 5 is, of course, minus 15. Maybe that one was a little too soft. Alright, so we are now expert in adding and subtracting real numbers. and I want to move up the ladder and start talking about multiplication. How do you multiply real numbers? Well, we all know that from our first course in algebra that a negative times a negative is a positive, and minus 4 times minus 7 is, of course, going to be positive 28. Enough said on that one. How about dealing with fractions? Minus 7/9 times 3/16. Now, this is an implied multiplication. There's really no multiplication symbol. We could put one in there if we want. All right, the idea here is to cross-cancel first. Right? Well, 7 and 16 are relatively prime. They contain no common factors, but 3 does go into 9 3 times. And if I multiply what's left, minus 7 times 1, anytime I cross out everything in a particular numerator or denominator, the invisible 1 becomes apparent. Minus 7 times 1 is minus 7, and downstairs 3 times 16 is 48. So minus 7/48 is going to be my completely simplified answer there. How about a string of 3 negative integers being multiplied? Well, of course, we know that multiplication is commutative, multiplication is associative, which means, of course, we can multiply these numbers in any order we like. We usually read left to right, so I think the tendency is to go left to right on these. Sometimes that works, sometimes it doesn't work, as we'll see in a couple later problems today. All right, minus 4 times minus 9 is positive 36, and 36 then times minus 3 is negative 108. So negative 108 would be your final completely simplified answer there. All right, we've added, we've subtracted, we've multiplied. And what's left? Well, we've got division. How do you divide real numbers? Well, at this point, it's going to be integers and fractions as well. Minus 44 over 11. Well, of course, we know 44 is 4 times 11. So what I can do is, well, I can write this as 11 times minus 4 over 11, could I not? And I get a cancellation across the fraction bar. Anytime you've got common factors across a fraction bar, they can cancel out, and I'm left with negative 4. Right, so minus 44 over 11 equals negative 4. How about 2/3 divided by minus 3/5? Again, not all numbers are integers. Right? Fractions are numbers too. So sometimes we divide fractions. Well, I'm betting that you've heard in your mathematical careers keep, change, flip. When I was young, it was invert and multiply. Essentially what we do is invert the divisor fraction. Here it's minus 3/5, and convert it into a multiplication problem. So in the large scheme of things, dividing fractions is much like multiplying fractions. It's multiplying by the inverse fraction of the denominator expression. All right, what do we do from here? Well, I see nothing going on. 2 and minus 3, nothing cross cancels. No simplification can go on here, so I'm just going to multiply across. 2 times 5 is 10, divided by 3 times minus 3 is minus 9. All right, so that would be a perfectly acceptable answer, 10 over minus 9. As you probably know, we can absorb that negative sign in either the numerator or denominator, or even leave the negative sign outside the division process, and all three of these expressions are equivalent. And any one of them would be acceptable on test day or homework day or any other day. Okay? Minus 10/9, final answer. Let's try another one. Minus 1/2 divided by, that's a division there, minus 6. Well, what are we going to do here? I believe this one's out of your homework assignment. You're taking a fraction and dividing by an integer, well, the negative of a whole number. What can we do? Well, we know how to divide by a fraction. We invert and multiply, but I don't see any fraction here in that minus 6 slot. Well, what I can do is rewrite minus 6 as minus 6 over 1 equivalently. I think you can agree, I think you'll agree that we can do that. So then minus 1/2 times 1 over minus 6 would be the resulting multiplication problem. I'll get then minus 1 over minus 12, which of course reduces to 1/12. This is our final, completely most simplified answer. Okay? All right, let's try another one. Dividing fractions, minus 7/8 divided by positive 2/3. Keep, change, flip. Keep the divisor expression, change the sign from division to multiplication, and flip. In other words, invert the divisor fraction in this problem. So I'll get minus 7/8, change it to a multiplication problem, times 2/3 inverts to 3/2. Minus 7/8, minus 7/8 times 3/2 would give me minus 21 in my numerator divided by 16 in my denominator. So no cross canceling going on here. Nothing I can do but multiply across and get the result minus 21/16. Okay. Alright, we've added, we've subtracted, we've multiplied, we've divided real numbers. In other words, integers and signed fractions. All right, now I want to talk about powers and roots. And of course, things that you've seen in your mathematical careers before. If I ask you to evaluate 2 cubed, well, what's 2 to the 3rd power? Well, we all know that's just 2 times 2 times 2. It's 3 factors of 2, the base, being multiplied together. And of course, 2 to the 3rd power is 8. So your final answer here is 8. All right, this is an exponent expression. We call this 2 here the base. The 3 is called, of course, the exponent. And if I have x to the nth power, just to define what it means to be an exponent, basically all that means is you've got n factors of x. Kind of a shorthand for extended multiplication. N factors of x. So if you're raising x to the nth power, you're multiplying x really by itself n times. Let's try, oh, hang on, I jumped the gun. Book makes a big deal about this one, minus 2 to the 4th power. Alright, minus 2 to the 4th power, well, by definition, it's minus 2 times minus 2 times minus 2 times minus 2. I'm guessing most of us can do this in our heads. Minus 2 times minus 2. Well, anytime you've got an even number of negative numbers being multiplied, you're going to end up with a positive return. I think we can all agree with that. Minus 2 times minus 2 is positive 4. 4 times minus 2 is minus 8. And minus 8 times minus 2 is positive 16. Okay? Contrast that last problem with this one. Minus 2 to the 4th power. Again, the book makes kind of a big deal about this. Evaluate negative 2 to the 4th power. Well, really what is happening here is there's invisible parentheses. We'll talk more formally about order of operations in a minute. The exponent operation gets done first. So when I see minus 2 to the 4th power, this negative sign out here is not really involved in that exponent process. So it's the negative of 2 to the 4th. Well, that's 2 times 2 times 2 times 2. That's 16. And the negative of 16 is, of course, negative 16. So if we write minus 2 to the 4th power, of course we know from our previous problem that's positive 16, but if I've got minus 2 to the 4th power with that negative sign outside that exponent process, that's going to return a negative 16. So beware of that. The book tries to trip you up a couple of times on problems like that. Alright, let me get a fresh screen here. Okay. How about evaluate? Evaluate 3/4 to the second power. Well, what does it mean to raise a fraction to the second power? Well, what does it mean to raise anything to the second power? You take 3/4 and you multiply it by itself, essentially, right? 3/4 times 3/4. Of course, there's no cross-canceling going on here, so basically I'll just multiply across. I'll get 9 in the numerator divided by 16 in the denominator. Of course, you might see that you can just distribute this exponent over the numerator and denominator. 3 squared is 9. 4 squared downstairs is 16. So, easy enough to see my final return is 9/16. Another one. Evaluate 2/3 cubed. Now I know there's shortcuts that we haven't talked about yet here, at least not formally. Well, 2/3 to the third power, that means you've got 3 factors of the base, 2/3 multiplied together. And nothing cross-cancels here. 2 and 3 are what they call relatively prime. So I have no choice but to multiply the numerators across. I get 2 times 2 times 2 is 8. Downstairs, 3 times 3 times 3 is 27. And a final return of 8/27. Alright, so we've talked about powers of whole numbers and integers and some fractions. How about some roots? Evaluate the square root of 121. Well, I imagine everyone that's been through a Math A course or a Math 9 course knows that the square root of 121 is 11. And the reason is because 11 squared is 121. Let me write that down. Because 11 squared is 121. In other words, 11 is the number I square to get 121. How about another root expression? Minus the square root of 49. Now please notice, this negative sign happens outside of the root operation. Right? So I evaluate the square root of 49 first, which is of course 7, and then attach the negative sign on my final answer. So minus root 49 is of course minus 7. Another root. Evaluate the square root of 4/25. Well, the square root of 4 is 2, and downstairs the square root of 25 is 5, right? This suggests that you can distribute a root sign over a fraction. In other words, take the root of the denominator and numerator independently. In any case, the square root of 4/25 is 2/5. One more root. Evaluate minus square root of 400. Well, the square root of 400, I believe that's 20, is it not? 20 times 20 is 400. And minus the square root of 400 would be minus 20 then. Alright. Last topic I want to talk about today is order of operations. And let's see, I got 1, 2, 3, 4, 5, 6, 7 examples of this very important topic. All right, so stay tuned out there, stay awake. Order of operations. Well, I imagine we've heard PEMDAS. It's a little mnemonic device from a typically seen first in a first algebra course, that tells me what order I evaluate operations in when given a expression with stacked operations. Parentheses or parenthetical operations. Operations isolated by symbols of grouping always get done first. And if there's more than one, we work from the inside out, as you might expect. After parentheses are cleared, then I start dealing with exponents. Then, multiplication or division, in order from left to right. Multiplication or division Right? Within this line, we go left to right, and then addition or subtraction, again in order from left to right. And please excuse my dear Aunt Sally, some call it PEMDAS. Let's jump right to an example. Let's say we encounter a problem and it says to evaluate the following expression. Minus 5 plus 4 times minus 3 squared. Well, even in a simple problem, we got a lot going on here. We've got an exponent, we've got parentheses, we've got a multiplication, and we've got an addition, and only one operation gets done first. If I look for parentheses, there's nothing really going on inside this parentheses. It's just a minus 3. So I can move to the next level, would then be exponents. So the next highest in the hierarchy of things is minus 3 squared. Alright, so minus 3 plus 4, I'll leave all the other operations pending, and minus 3 squared is, of course, positive 9. Minus 3 times minus 3 is positive 9. Alright, now I've got an addition and a multiplication. Which gets done first? Well, of course, the multiplication always takes precedence over addition, so minus 5 plus 36 would take me down to the next line, and minus 5 plus 36 is, of course, 31. Alright, order of operations. Very important and kind of easy to mess up if you don't practice enough on these, so please be sure to practice on the homework problems. Try another one. Evaluate. Minus 10 divided by 5 minus 5 times 3 plus 6. Alright, PEMDAS. Please excuse my dear Aunt Sally. You've heard it a million times, right? Well, there is a parentheses, but nothing going on inside of it, so I can't really evaluate any parentheses operations. Exponents, no exponents going on here. What's next? Multiplication or division in order from left to right. Now this is the first multiplication or division. Right? It's not always multiplication first. Right? It's multiplication or division, whichever comes first, left to right. So I do this first. Minus 10 divided by 5 is minus 2. Is it not? Alright, let me leave all other operations pending. Now what? Well, I've got a subtraction, a multiplication, and an addition, and of course the multiplication takes precedence over any addition or subtraction. So minus 2, I'll have minus 5 times 3, that'll turn into a negative 15 in between. Oh, sorry, I made a copy error there. Right, 6 plus 6 plus 6 plus 6, yes, okay. Alright, so minus 2 minus 15 is negative 17, going in order from left to right there. And minus 17 plus 6 is, of course, negative 11. So my final return there would be negative 11. Alright. You flip to the last page here. No, not quite the last page. We've still got a bunch to go. Something a little harder. Alright, evaluate the following expression. Alright, we've got two symbols of grouping here. We've got the brackets, and we've got the more familiar parentheses. And remember PEMDAS. If you're working on parenthetical operations, you work from the inside out. So I'll work on that piece of the problem first and leave all other operations pending. 4 minus 3 squared. Well, I'm not going to write a new line of code for every single operation. We'd be here all day. 3 squared is 9, and 4 minus 9 is, of course, minus 5. So there I can get away with combining two steps in one. All right, now I go for the brackets here. What's going on inside these brackets? Well, I've got a subtraction and a multiplication. Of course, multiplication always takes precedence over subtraction. So I'm going to leave all other operations pending and multiply minus 8 times minus 5 is going to be plus 40. All right, now notice there's a common mistake here. Someone, maybe too many people would do 5 minus 3 next. This is actually the last operation, okay, according to your agreed upon order of operations. So I'll do this operation next. Minus 2 plus 40, 5 minus 3 times 38. Alright, now we've got a multiplication and a subtraction. And again, multiplication always takes precedence over subtraction, so I do the multiplication first. 5 minus 3 times 38 is minus 114. And only now do I perform this first sign that I see on the left, going left to right anyway. 5 minus 1. Oop, hang on, I made a mistake. Hang on. 3 times 38, 120, 144, right? So 5 minus 144, not 114. Please make that correction. 5 minus 1, I'm sorry, 2. Hang on. 5 minus 144. Hang on. Let me pause. Alright, apparently I did not make a mistake. Originally, you looked at the wrong piece of the paper I'm working from here. Please forgive me. So 5 minus 114 is minus 109. Okay? 5 minus 114 is minus 109. Alright, let's try another one. Evaluate. 2 plus 3 times minus 2 times 5 squared minus 3 minus 4. Alright, again, PEMDAS. I'll work from the inside out. 2 plus 3 times minus 2. I'll evaluate this expression first. 5 squared is 25. 25 minus 3 is 22. Okay. Now I'll go to the brackets here. Working from the inside out of nested parentheses, leaving all other operations pending. Well, minus 2 times 22 is minus 44, and minus 44 minus 4 is minus 48. That looks better already. Now I've got a multiplication and an addition, and of course multiplication always takes precedence over addition on the same line of code. So I'll say 2 plus, well, 3 times minus 148 is minus 144. And minus 144 plus 2 is, of course, negative 142. So that's my final return for that expression. All right. 3 more to go. These are all evaluation type problems. Well, let me give you a simple one first. Evaluate this variable expressions. We really haven't talked about variables yet in this course. Evaluate minus 1/2 a squared if a equals negative 2. Well, all that means is you plug in minus 2 for A and grind out a numerical answer according to your order of operations. Alright, minus 2 squared is positive 4. And of course, 2 goes into 4 twice, and 2 times minus 1 is minus 2. So a simple example there of variable evaluation. Let's do something a little harder. Let me get a new layer here. Hang on. Evaluate. This one's a little tougher. Minus a root b plus 3c squared divided by c times c minus b if a equals minus 2, b equals 9, and c equals minus 1. Alright, now be careful. When you're substituting, or when I'm substituting in negative values for a variable, I always wrap it in parentheses. So I'll get minus a times the square root of b plus 3 times c squared divided by c times c minus b. Alright, what are we going to do here? Well, this fraction bar really acts like two big symbols of grouping, isolating numerator from denominator. So essentially I can evaluate the numerator and denominator in this problem independently, maybe save some time. Let me look at the denominator here. Here's a set of parentheses. That's in the denominator, that gets done first. Minus 1 minus 9 is minus 10, and minus 10 times minus 1 is positive 10. Everybody agree? Let me do that again. Minus 1 minus 9 is negative 10, and negative 10 times negative 1 is positive 10. Alright, so my denominator reduces to a positive 10. What's the numerator going to look like? Well, the square root of 9 is 3. 3 times minus 2 is minus 6. And minus 6 times negative 1, or the negative of negative 6, is positive 6. Alright, so this left branch of that numerator sum reduces to a positive 6. Plus, well, remember, minus 1 squared, that's negative 1 times negative 1, that's positive 1. And 1 times 3 is 3. So I end up with 6 plus 3 over 10, and that reduces, of course, to 9/10. Alright, one more, we'll call it a day. For section 1.3 anyway. Evaluate. Alright, we've got three fractions here. We've got fractions being multiplied and fractions being subtracted. Well, which operation gets done first? PEMDAS. Of course, we'll multiply first and then subtract later. Alright, we've got some cross cancellation to go out here. Well, negative of a negative is positive. 3 goes into 6 twice. 3 goes into 9 3 times. So I can multiply that first branch of this expression, and I get 3 in the numerator. 3 times 1 over 8 times 2 is 16. And of course now a minus 5/12 is plus 5/12. So I've got to combine these two fractions now, and getting a common denominator. I believe the least common multiple of 16 and 12 is 48, is it not? Alright, so I'll multiply top and bottom of the first fraction by 3. Multiply top and bottom of the second fraction by 4. Now I've got a common denominator, and the final return would be 29 over 48. So 29/48 would be our final answer. Alright, we're approaching the 36-minute mark, so I'm going to call it a day. 36-minute mark. So this concludes our lecture on section 1.3, operations with real numbers.